All right, so we're going to refer back to this list. Some of the things that you wrote down on this list, like build the other side, you don't know what that means yet. Multiply by 1 the conjugate. These are some strategies that we're going to use. We're going to have this list available to us, and then I'm going to refer back to it as we do some proofs. So right now, some of you are working on example A, and some of you are working on example B, and we'll put up some of those in a second. All right, so here's the first one. Excellent. Here on the right-hand side, we got the line drawn. We changed cosecant to 1 over sine and secant to 1 over cos. So on our right side, we've got 1 over sine times cos. And that's a single fraction, so that's a good place to stop on the right-hand side. On the left side, change cotangent to 1 over tan. Looks like we're trying to get a common denominator here. So we got tan on the bottom, and they're multiplying by another tan on the top, which gives us tan squared. Okay? This one, at this point, the person has started to forget thetas. All right? So there's another one. So this would be a lot of thetas that I'd have to add when I'm marking this. The nice thing is if you're going to forget one theta and you're going to make me take off the half mark, may as well forget them all so your paper comes back crazy like this. So careful with that. Now we've got a common denominator, so we've got 1 plus tan squared over tan theta. Things started going wrong over here, but then it went from here to over here. 1 plus tan squared is equal to secant squared. So now we've got secant squared theta over tan. Secant squared is 1 over cos squared. And tan is sine over cos. Now we have a fraction divided by a fraction. Got to keep adding thetas. Here we go. There's a missing one here, there. Oh, and they came back in the end. Nice. And so now we can multiply by the reciprocal, and then your coses cancel out, and you're left with 1 over cos theta sine theta, and this proof would work. So great. So this shows that when we see this proof, and we're going to see 2 more of part A, they're all going to be different, and they're all right. As long as the step that comes after is equal to the step before, it works. Now we're going to see some proofs are going to be shorter than others, and we're also going to learn when we go back to our strategies list, what are some of the strategies that can make them shorter? Or what are some of the strategies we can use so that they become more streamlined? Because what's happening in this one is each time you're going to step, you're like, I don't know where I'm going. And when you don't know where you're going, you're just doing the next step and doing the next step. It could take a long time before you get to where you want to end up. It's not wrong, and this is perfectly good proof, but we're going to learn some strategies to help us go there faster. So here's our second one. Our second one, again, they changed the right side to 1 over sine theta cos theta. Again, on the left side, they changed to 1 over tan and tan squared. This one's very similar. They changed the tan squared to secant squared minus 1. So it's kind of the same idea as the last one. And then changed the secant squared to 1 over cos squared, and eventually got the same thing without forgetting the thetas. So I would say this proof is very similar to the last proof that we saw. This third one here, this is going to be a strategy you're going to use a lot. This is going to, although it looks a little bit crazy at the beginning here, this is a really good strategy. Changing things to sine and cos. Because on the right side, with both the first 2 proofs, we changed to 1 over sine and 1 over cos, which was good. But we notice, what is our right side? Our right side has sine and cos. So in the first 2 proofs, changing things to tan on the left side is going to take a little bit longer. Because if you change things to sine and cos right away, at least both the left side and the right side of the equation are in the same function. And if you have sine and cos on the left, sine and cos on the right, usually it's going to be a little bit quicker. So here, if you change to sine and cos, again, you need a common denominator. This one, what the person did is they multiplied this by cos over cos, and this by sine over sine to get a common denominator. And then what do you get? You get cos squared plus sine squared over cos times sine. And what's cos squared plus sine squared? 1, and you're done. So this person, as far as seeing steps that you could probably even skip, once you show that you're getting a common denominator, you could probably go right from here to here if you wanted, because that would be your common denominator and adding your tops, and then right to here to the proof. So this proof goes even a little bit quicker than the last proof, and it shows one of our strategies of changing everything to sine and cos. I think that's my last one of example A. Let's look at some from example B. Okay. And I tried to organize them to go from the longest proofs that I collected from you guys to the shortest ones. So we'll see the shortest ones at the end. Okay. So here, the person got a little frustrated in the middle, wanted to put an X, and I said, everything is good so far. You can keep going with this. Nothing's wrong. But sometimes you're going to feel that. You're going to feel like you're stuck. So this side they changed to tan. They changed each of those cotangents to tan, and they changed cosecant squared to 1 over sine squared. They did a good job here of seeing I need to get a common denominator, so this 1 over tan is missing a sine squared. They got a common denominator. They got 1 minus sine squared over tan sine squared. They recognized that 1 minus sine squared is equal to cos squared. So those trig identities, these ones up here, sine squared plus cos squared equals 1. Tan squared plus 1 equals secant squared. Cotangent squared plus 1 equals cosecant squared. I told you the other day you need to have them memorized. You say, well, they're on our formula sheet. Well, you need to have them mostly memorized or almost completely memorized. You could check on your formula sheet just to verify it. But what happens in a proof is partway through the proof, right here, you get 1 minus sine squared. If you don't have that memorized, you're not going to think about changing it to cos squared. You're just going to get stuck. But if you have it memorized, that's going to come to you right away. Oh yeah, 1 minus sine squared is cos squared. So I can change that, and that's going to help me. And then at this point, what the person did is they noticed cos squared over sine squared. Cos over sine is cotangent, so cos squared over sine squared is cotangent squared. And then they could change that cotangent squared to 1 over tangent squared. We got a fraction over a fraction, multiply, and we get 1 over tan cubed. Done. So this one, the strategy moving along was to change everything to tan. Here is our next proof. Good. I really like this proof because it shows what does it look like to change things to all cos and all sine. So cotangent is cos cubed over sine cubed. Cotangent here, cos over sine, cosecant 1 over sine, cotangent cos over sine. So the nice thing about changing everything to sine and cos is you can always do that. You can always change everything to cos and sine. Now if we get a single fraction, we're going to see how close we are to being the same. So we got a common denominator here of sine cubed. Feels a little bit weird working with things that are cubed because you feel like, oh, something's going to go wrong. At the top here, we could factor. Let's see. Oh, no, instead of factoring, they changed the sine squared to 1 minus cos squared. Because another thing on your strategy list, as I said, was be aware of the other side. Do you remember writing that down? Okay. What that means, and I think this person is using that strategy at this point. On this side here, they noticed that the top is only in cos and the bottom is in sine. So when they got to this point here, they said, this is good. The bottom of my function's in sine. That's what I want. But the top of my function has cos and sine. It would sure be nice if I had a way to change the sine to a cos. And so sine squared is 1 minus cos squared, so they just substituted that in there. And then distributed the cos, and what did they notice? The coses cancel out. We got cos cubed on the top now over sine cubed, and we're done our proof. So this one I think is a good example of that strategy of being aware of the other side. My other side that was simplified had a cos cubed on top. So if I changed this to have a cos cubed, that'll help me. That my top of my fraction is all in cos. So this is an example of changing things to sine and cos. Again, a very powerful strategy that often will result in the right answers. Now the last two that I have here are the shortest proofs that I collected from you guys. This one said, I will have cotangent on the left. Maybe there's a way to change everything to cotangent on the right. So I'm going to avoid changing to sine and cos. And if you can avoid changing to sine and cos, you can often find the quickest proof. And in this case, once they factored out the cotangent, they got cosecant squared minus 1. And they had the formula memorized, or at least they had it partially memorized, at least to look up. They said, hey, I know that cosecant squared is equal to cotangent squared plus 1. So they changed this cosecant squared here to cotangent squared plus 1. And then the 1's cancel out, and we get cotangent times cotangent squared and cotangent cubed. And the last proof is basically identical, except in this one, the person said, I have that formula memorized, and not only do I have it memorized, but it's really easy to move the 1 over to the other side. So cosecant squared minus 1, if I look at that formula, is equal to cotangent squared. And so they just substituted directly and saved one extra little tiny step and got the proof right away. So when we look at this proof, which is only 1, 2, basically 3 lines, compared to some of the first ones that took a little bit longer, right? There are ways to prove these quicker, but it's not wrong if you take a longer route. But your goal in doing these is to always sort of say to yourself, when you finish a proof, you might look at it again and say, could I do that quicker? Is there a better way of doing that? I'm going to add one proof to this. So we're going to add a part C here. Okay, you can do this on your scrap piece of paper. We had one with cubes. I'm going to add one with a power 4. We want to prove that tan to the 4th minus secant to the 4th is equal to tan squared, negative tan squared minus secant squared. Let's see, is that right? Can't. Yeah. Okay. One of our strategies, when we go back to our list of strategies here, one of our strategies, we've all talked about a bunch of these, but one of the strategies that we haven't seen yet is factoring difference of squares, if possible. So on this one, so we sort of have to have our list of strategies kind of memorized as well, that when you get stuck, you have to sort of go through your list of strategies to see if you can see something to do. Can you see that on the left side, it is a difference of squares. And so you can factor this as tan squared and tan squared. One will be plus, one will be minus, and then secant squared and secant squared. Now when you do that, you say, oh, I know that tan squared and secant squared are related. Is there a way that I can rearrange my tan squared plus 1, right? This is our... Can I rearrange that to get tan squared plus secant squared? Or can I rearrange that to get tan squared minus secant squared? It's only going to work for one of them. Which one, the first one or the second one? The second one. Can you see there's no way that you can rearrange this to get tan squared plus secant squared, because as soon as you move the secant squared over, It's going to be minus. But what is tan squared minus secant squared equal to? It's equal to a -1. Can you see that you would have to move the secant squared to this side and move the 1 to that side? In which you get tan squared minus secant squared is equal to -1. And then if you distribute this, and we're done.